According to the National Electrical Code, specifically Section 230.3a, on type MI cable is permitted for use in wet or dry locations. It can be installed in raceways, on surfaces, or even buried directly in the earth. Section 230.2d stipulates that metal-clad cables must be grounded and bonded according to Article 250. Regarding fire code considerations, the National Fire Alarm and Signaling Code, NFPA 72, does not specifically prohibit the use of MI cable inside a building. However, the Life Safety Code, NFPA 101, may have additional requirements for the installation of fire alarm systems, including the type of cable used. There are several additional factors to consider. Firstly, electromagnetic interference, or EMI. MI cable provides excellent EMI protection, which can be beneficial in areas with sensitive equipment. Secondly, environmental conditions. MI cable is designed to withstand harsh environmental conditions, including moisture and temperature extremes. Thirdly, fire resistance. The metal cladding of MI cable offers some level of fire resistance. The ultimate determination of whether MI cable can be used inside the building depends on the specific requirements of the jurisdiction and the fire code. Recommended steps include firstly checking with the local building inspector or fire marshal to verify if there are any specific restrictions on the use of MI cable inside buildings. Secondly, reviewing the installation specifications provided by the engineer and ensuring they comply with applicable codes and standards. Thirdly, if there are any concerns or discrepancies, consult with a licensed electrician or qualified engineer for guidance. In conclusion, based on the National Electrical Code and general fire safety considerations, using MI cable inside a building supplying a fire pump control panel is acceptable, provided it is properly installed, grounded, and bonded, and meets any applicable fire code requirements. Consulting with the appropriate authorities to confirm specific requirements is highly recommended. The decision to use mineral-insulated cable, commonly referred to as MI cable, within a building to supply power to a fire pump control panel involves several considerations based on the National Electrical Code, abbreviated NEC, and relevant fire safety standards. MI cable offers distinct advantages, but its application must align with the specific requirements of the installation and local regulations. The NEC addresses the use of service conductors in Article 230. Section 230.3a specifically permits the use of MI cable in various settings, including wet or dry locations within raceways, on surfaces, or directly buried in the earth. This versatility makes MI cable a suitable choice for the intended application, provided all other requirements are met. Moreover, NEC Section 230.2d mandates that metal-clad cables, including MI cable, be grounded and bonded in accordance with Article 250. Proper grounding and bonding are crucial for electrical safety, ensuring that fault currents can safely return to the source, thereby minimizing the risk of electric shock and fire hazards. Fire safety standards also play a significant role in determining the acceptability of MI cable for fire pump applications. While NFPA 72, the National Fire Alarm and Signaling Code, does not explicitly prohibit the use of MI cable inside buildings, it is essential to consult NFPA 101, the Life Safety Code, which may impose additional requirements for fire alarm systems and related equipment. NFPA 101 focuses on life safety provisions in buildings and structures, and it may include specific guidelines for the type of wiring and cabling used in fire protection systems to ensure reliability and performance during emergency situations. Beyond code compliance, several other factors warrant consideration when evaluating the use of MI cable. Electromagnetic interference, EMI, is a concern in many electrical installations, particularly near sensitive equipment. MI cable offers excellent EMI protection due to its metallic sheath, which acts as a barrier against electromagnetic radiation. This shielding capability can be advantageous in minimizing interference with nearby electronic devices and systems. Environmental conditions are another important aspect to assess. MI cable is designed to withstand harsh environments, including exposure to moisture, extreme temperatures, and corrosive substances. Its robust construction makes it suitable for demanding applications where other types of cables may be vulnerable to degradation or failure. Fire resistance is also a notable characteristic of MI cable. The metal cladding provides a degree of fire protection, helping to contain flames and minimize the spread of fire in the event of an electrical fault. While MI cable is not inherently fireproof, its fire-resistant properties can contribute to overall fire safety within the building. Ultimately, the decision to use MI cable inside the building must be based on a thorough understanding of applicable codes, standards, and local requirements. Consulting with local building inspectors or fire marshals is crucial to verify any specific restrictions or guidelines pertaining to the use of MI cable in fire protection systems. It is also essential to review the installation specifications provided by the engineer to ensure compliance with all relevant codes and standards. If any concerns or discrepancies arise, seeking guidance from a licensed electrician or qualified engineer is highly recommended. These professionals possess the expertise to evaluate the proposed installation and provide informed recommendations based on sound engineering principles. In summary, the use of MI cable inside a building to supply power to a fire pump control panel is generally acceptable, provided it complies with NEC requirements, fire safety standards, and local regulations. Proper installation, grounding, and bonding are essential for ensuring electrical safety and performance. Consulting with authorities and qualified professionals is crucial to confirm compliance and address any concerns related to the specific application. The following points should be considered in detail to ensure a comprehensive understanding and safe implementation of MI cable for fire pump control panels. Delving deeper into the NEC requirements, Article 230, which governs services, provides a comprehensive framework for the installation of electrical services, including the conductor supplying power to a building. Section 230.3 outlines the acceptable wiring methods for service conductors, with subsection A on specifically permitting the use of MI cable. This section explicitly states that MI cable can be used in wet or dry locations and allows for various installation methods, such as installation in raceways, on surfaces, or direct burial. The versatility of MI cable makes it suitable for different building environments and installation scenarios. However, it is crucial to adhere to the installation requirements outlined in Article 332, which provides specific guidelines for MI cable. Article 332 addresses issues such as securing and supporting the cable, protecting it from physical damage, and ensuring proper termination. Compliance with Article 332 is essential for maintaining the integrity and safety of the MI cable installation. In addition to installation requirements, proper grounding and bonding are paramount for electrical safety. As previously mentioned, NEC Section 230.2d mandates that metal-clad cables, including MI cable, be grounded and bonded in accordance with Article 250. Article 250 provides detailed requirements for grounding and bonding electrical systems and equipment, aiming to create a low-impedance path for fault currents to return to the source. Effective grounding and bonding help to minimize the risk of electric shock and prevent the buildup of dangerous voltages on metal parts. When installing MI cable, it is crucial to ensure that the metal sheath is properly grounded to the building's grounding system. This can be achieved by using approved grounding connectors and following the manufacturer's recommendations for grounding and bonding. Moving on to fire safety standards, it is essential to consider the requirements outlined in NFPA 72 and NFPA 101. NFPA 72, the National Fire Alarm and Signaling Code, focuses on the installation, testing, and maintenance of fire alarm systems. While NFPA 72 does not explicitly prohibit the use of MI cable inside buildings, it does specify requirements for the wiring and cabling used in fire alarm circuits. These requirements aim to ensure the reliability and survivability of fire alarm systems during emergency situations. NFPA 101, the Life Safety Code, provides comprehensive requirements for life safety in buildings and structures. It addresses various aspects of fire protection, including fire alarm systems, emergency lighting, and fire-resistant construction. NFPA 101 may include specific guidelines for the type of wiring and cabling used in fire protection systems to ensure they can withstand the effects of fire and continue to function during emergencies. When selecting MI cable for fire pump applications, it is essential to verify that it meets the requirements of both NFPA 72 and NFPA 101. This may involve choosing MI cable that is listed and labeled for fire-resistant applications and ensuring that it is installed in accordance with the applicable codes and standards. In addition to code compliance, it is also important to consider the specific environmental conditions in which the MI cable will be installed. MI cable is known for its ability to withstand harsh environments, including exposure to moisture, extreme temperatures, and corrosive substances. However, it is essential to select MI cable that is specifically designed for the intended application and environmental conditions. For example, if the MI cable will be installed in a wet or corrosive environment, it should be protected with a suitable jacket or coating to prevent degradation of the metal sheath. Similarly, if the MI cable will be exposed to extreme temperatures, it should be rated for the maximum temperature it is likely to encounter. Electromagnetic interference (EMI) is another factor to consider when using MI cable. As previously mentioned, MI cable offers excellent EMI protection due to its metal sheath, which acts as a barrier against electromagnetic radiation. This shielding capability can be particularly beneficial in areas with sensitive electronic equipment, such as hospitals, data centers, and industrial facilities. However, it is important to note that the effectiveness of EMI shielding depends on proper grounding and bonding of the MI cable. The metal sheath must be properly grounded to the building's grounding system to provide a low impedance path for electromagnetic currents. Finally, it is essential to emphasize the importance of consulting with local building inspectors or fire marshals before installing MI cable. Local authorities may have specific requirements or restrictions on the use of MI cable in certain applications or locations. Consulting with local authorities early in the design process can help to avoid costly delays and ensure compliance with all applicable codes and regulations. In conclusion, the use of MI cable inside a building to supply power to a fire pump control panel is generally acceptable, provided it complies with NEC requirements, fire safety standards, and local regulations. Proper installation, grounding, and bonding are essential for ensuring electrical safety and performance. Consulting with authorities and qualified professionals is crucial to confirm compliance and address any concerns related to the specific application. The information provided here is intended for general guidance only and should not be substituted for professional engineering advice. A comprehensive understanding of the relevant codes, standards, and regulations is essential for ensuring a safe and compliant installation. Now consider the following points regarding fire pump control panels and their specific requirements. Fire pump control panels are critical components of a building's fire protection system, responsible for starting and controlling the fire pump in the event of a fire. These panels must be highly reliable and capable of operating under adverse conditions such as power outages and exposure to fire. The NEC and NFPA provide specific requirements for the wiring and cabling used in fire pump circuits to ensure their reliability and survivability. NEC Article 695 provides specific requirements for fire pumps, including the power source, overcurrent protection, and control wiring. Section 695.6c requires that the supply conductors for fire pumps be installed in a raceway or B-type MI cable. This requirement is intended to protect the conductors from physical damage and fire exposure, ensuring that the fire pump can continue to operate during an emergency. NFPA 20, the standard for the installation of stationary fire pumps for fire protection, provides additional requirements for fire pump control panels and their wiring. NFPA 20 specifies the type of wiring and cabling that can be used in fire pump circuits, as well as the installation methods that must be followed. NFPA 20 also requires that fire pump control panels be listed and labeled for fire pump service. This listing ensures that the panel has been tested and certified to meet the requirements of NFPA 20. When selecting MI cable for fire pump control panel applications, it is essential to verify that it meets the requirements of both NEC Article 695 and NFPA 20. This may involve choosing MI cable that is listed and labeled for fire pump service and ensuring that it is installed in accordance with the applicable codes and standards. In addition to code compliance, it is also important to consider the specific environmental conditions in which the fire pump control panel will be installed. Fire pump control panels are often located in areas that are subject to moisture, extreme temperatures, and corrosive substances. Therefore, it is essential to select MI cable that is specifically designed for these environmental conditions. For example, if the fire pump control panel will be installed in a wet or corrosive environment, the MI cable should be protected with a suitable jacket or coating to prevent degradation of the metal sheath. Similarly, if the MI cable will be exposed to extreme temperatures, it should be rated for the maximum temperature it is likely to encounter. Proper installation of MI cable is also crucial for ensuring its reliability and performance. MI cable should be installed in accordance with the manufacturer's recommendations and the applicable codes and standards. This includes securing and supporting the cable properly, protecting it from physical damage, and ensuring that it is properly terminated. Grounding and bonding of MI cable are also essential for electrical safety. The metal sheath of the MI cable must be properly grounded to the building's grounding system to provide a low impedance path for fault currents. In addition to grounding, it is also important to bond the metal sheath of the MI cable to the fire pump control panel and other metal parts of the fire protection system. Bonding helps to minimize the risk of electric shock and prevent the buildup of dangerous voltages on metal parts. Regular inspection and maintenance of MI cable are also important for ensuring its long-term reliability. MI cable should be inspected periodically for signs of damage or degradation. Any damaged or degraded MI cable should be replaced immediately to prevent electrical hazards. In summary, the use of MI cable in fire pump control panel applications is generally acceptable, provided it complies with NEC Article 695, NFPA 20, and local regulations. Proper installation, grounding, and bonding are essential for ensuring electrical safety and performance. Regular inspection and maintenance are also important for ensuring long-term reliability.